Again, welcome to Python programming language. This is CS 101. This lectures cover loops or repetition structures. And this lectures cover chapter 4 of our course textbook, how to use, again, loops in Python programming. So our main objective is to go through the repetition structures, why we use them in programming language. And also we're going to discuss about the two types of loops in repetition structures, which is the while loop and the for loop. We're also going to discuss about what we mean by Sentinel values, and also how to validate an input using loops, and also how to use nested loops. So often we may write a code that performs the same task multiple times. So it means, for example, if I want to print hello world 10 times, I have to write the print statement 10 times. But there's a disadvantage of duplicating the code, because in this case, I'm writing the same print hello world 10 times, duplicating it 10 times. This will make our program very large, and also it's time consuming. It takes time to write the code, and also may need to be corrected in many places. Now, repetition structure solve this problem for us. Repetition structure will make computer repeat included code as necessary. So in this case, I can use while loop or for loop, and I'm going to write print hello world only once instead of 10 times or 100 times. Then I'll write this code, only one code in a loop, and I'll give the condition to the loop that it should execute it either 10 times or 100 times. So that's the main advantage of a repetition structure or loops. It makes it possible for us to eliminating duplicating a code. If I want to write a code to perform a task multiple times, I'll write the code only once and then put it in the loop condition to repeat itself as many as I want. So we start with the while loop. We say the while loop is a condition control loop. A condition control loop means we don't know how many times the loop will execute. Everything depends on the condition. So here we say while loop, while the condition is true, do something. When the condition is false, the loop will stop. We have two parts in a loop. We have the condition tested for true or false, then the statement repeated as long as the condition is true. So this is the syntax for the Python while a condition execute a statement. So in Python, the word while is a keyword. And this is the flowchart. So we have a condition. Again, in sequential control structure, we said execution starts from up, down. So we are coming the arrow down. We check a condition. If the condition is true, we are going to execute our statement. Then we come and check the condition again. If it's false, we come out of the loop. So in order for a loop to stop executing, something has to happen inside the loop which will make the condition false. If the condition can never be false, then we have what we call the infinity loop. The loop will keep executing over and over and over again with no, again, stopping. So test condition before performing an iteration, and it will never execute if condition is false to start with. Require performing some steps prior to the loop. So let's start with a very good example here. We have an open problem here. We want to print programming is fun 100 times. Well, if we print it 100 times, it makes our program very large, and also it's time consuming. And anywhere we make a mistake, we have to correct it. So we have to correct many places. So the best way to solve the problem, we are going to write the statement once, print programming is fun, and we put it inside the loop. Here we are using while loop. So our condition is while the counter is equal to 100, print programming is fun, and increment the counter. Increment the counter is very important, because if we don't increment the counter, we are going to have infinity loop, which means the count start from 0, the variable count start from 0. So it will be always 0 is less than 100, yes. 0 is less than 100, yes. So the loop will keep executing forever. But we have increment the counter by 1. So this means if you start from 0, next it will be 2, next it will be 3, all the way to, let's say, 97. Is 97 less than 100? Yes, we execute program is fun. We go up to 99. Is 99 less than 100? Yes, we execute. Now, when we increment by 1 to 100, is 100 less than 100? No. So that's when the loop will stop. So we shall go through the statement one more time. So here we have the condition. The loop condition is true. We execute our statement, then we check the condition again. So we can see the arrow is going back to the condition again. And then if the condition is false, we come out of the loop. So this is our program again. We start with the counter from 0. We say while the count 0 is less than 100, print program is fun, increment the count to 1. Then we check is 1 less than 100? Yes. Program is fun. We keep doing it until the condition is false. So let's go through the while loop again. So first, we initialize our count. Again, the counter, we can initialize it to any value. Yes, let's say, for example, here we want to print program is fun only twice. I can initialize my counter to 2, and I'll go up to 4. So from 2, 3. So I'll say count equal to 2, count is less than 4. So I'll go 2 and 3. In the 4, is 4 less than 4? No, I stop. So initialization, traditionally we start from 0, but you can start from any value. So we initialize our count variable to 0. Then we check the condition. 0 less than 2 is true, okay? Then we're going to print program is fun. Then we increment our count. This time the count will be 0 plus 1. So our new count now is 1. So we are going to check the condition is 1 less than 2. Yes. Then we print program is fun again. We increment the counter to 2. Then next we check is 2 less than 2 false. So if this is false, the while loop will stop. So we come out of the while loop. We exit the while loop. So we discussed the infinity loop means the condition can never be false. So loops always must contain within themselves a way to terminate a condition. It should give us some way that the condition to be false will occur. If it doesn't occur, then we have infinity loop. So we say a loop that does not have a way of stopping. It will repeat until program is interrupted. This normally occurs when the programmer forgets to include the stopping code in the loop. So next we go to the for loop. And the for loop is count control loop, which means we know how many times the loop will execute. So a count control loop will iterate a specific number of times. We use for statement to write the count control loop. Also designed to work with a sequence of data items, iterate once for each item. So a good example, the keyword for whatever the variable is in var1, var2, etc. So let's say we go var1 and var2, which means the for loop will execute only twice. So this example here, we have for loop. For num is our variable in 1, 2, 3, 4. So this tells us that the first is 1. So when num is 1, we are going to execute our statement here, print num. So you're going to print 1 because num is 1. Then next, it will move to 2. When num is 2, we also print num. So we are going to print 2. Then we move to the next. Num is 3, we print 3. Next, num is 4, we print 4. Next, 5, num is 5, we print. The loop will stop. So this is again called the count control loop. We know how many times the loop will execute. And now sometimes we can use a range function to simplify the process of writing the for loop. So for example, instead of writing, let's say if I want to print numbers from 1 to 100, I don't want to write 1, 2, 3, 4, 5 up to 100. Then it's like we are going back to a statement where we don't need the loop. So in this case, we can use the range function. Then we can simplify that. We want to go, the argument of the range will be up to 100. Let's say from 0 to 100, it will print from 0 to 99. Or we make it 101 to go up to 100, from 1 to 100. So the range return an iterable object. Iterable object normally contains a sequence of values that can be iterated over. So if I say range 5, then it will return 0, 1, 2, 3, 4, up to 4. Then the range characteristics can be only one argument used as an ending limit, or two arguments. We have the starting. For example, we may have two arguments from 1 to 5, which means we go from 1 to 4. But if I have 5, I'll go up to 4. Then also we can have the third argument, which will tell us the step values. For example, we have 1, 10, 3. It means from 1, I will move to 4 because it's 3 steps. Or I have 1, 10, 1. It means I'll go 1, 2, 3, 4, 5, up to 10. And again, we're going to see examples soon. Now, the purpose of a target variable is to reference each item in a sequence as the loop iterates. So a target variable can be used in calculations or tags in the body of the loop. Example, let's say calculate the square root of each number in a range. Again, we're going to see an example soon. Also, letting the user control the loop iterations. Sometimes the programmer does not know exactly how many times the loop will execute. So we can receive a range input from the user, place them in the variables, and call the range function. So for example, I may have an input function that the user should enter a number. And that very variable, I will use it as argument in the range function. So if user enter 10, then I'll go up to 9. Or we tell the user to enter initial number and the ending number. Then those two variables where those two values are stored, we are going to use it in our range function as the argument. Or the best way, if we don't know how many times the loop will execute, then we use the while loop also, as we said earlier. Now, generating an iterable sequence that ranges from the highest to lowest. And previously we said lowest to, now if I want to generate a number from lowest to highest, it's easy. I can use only one argument. If I use 10, then I'll go up to 9 in sequential order. But if I want to go in decreasing order, then we have to have the third variable, the step value. So for example, here we have range 10, 0, -1, which means we are starting from 10, and -1 means we are going to reduce by 1. So it will go 10, 9, 8, 7, up to 0. Now let's see more example with the range. So for example, here we have range A and B. Now for V is our variable in a range 4 to 8. Print V. So the first V will be 4. It will print it. It will print 5. It will print 6. It will print 7. But when you reach 8, it will stop. The range 4 to 8 means we go from 4 to 7. And we can see the example here. Now here we say for I in range 4. Range 4 means we start from 0, we end at 3. So print I 0, 1, 2, 3. Here we have the step, which is our third value. So we have for V in range 3, 9, 2. We are going to start printing from 3. So print V. V is 3. The next V will be 5 because we have 2 steps. So from 3 to 5. The next one will be 7. 2 steps again. But from 7 to 9, we can't print 9. So we end there. So here we can see our output. First 3, step 2, plus 2 is 5, plus 2 is 7, plus another 2 is 9. We can't print 9. Now, if it's from 3 to 10, then we can print 9. And this is again the decreasing order. So we say for V in range 5 to 1 and -1. So it's going to print, and we are printing the V. So it's going to print 5, 4, 3, and 2. So we get 5, 4, 3, 2. Now let's see example here. This is a for loop, a count control loop, a very simple loop, 1.py, which is the file name. Here, this program will demonstrate a simple for loop that uses a list of numbers. So here we have print. I will display the numbers 1 through 5. So we can see here for num in 1, 2, 3, 4, 5. Print num. So you're going to print 1, 2, 3, 4, 5 as shown here. The next example, which is loop simple loop2.py, we see again this program also demonstrates a simple for loop that uses a list of numbers. So here we say for num in 13579, and we are printing the num, so which means it's going to print 13579, and that's the output here, 13579. Now let's say calculating a running total. Here we say programs often need to calculate a total of a series of numbers. For example, calculate a total number from 1 to 100, which means 1 plus 2 plus 3 or 200. Typically, to include two elements, a loop that read each number in a series, and also we should have accumulator variable. So for example, sum equal to sum plus I. Let's say I is our variable. So now sum become accumulator variable. So this is known as program that keep running total, accumulate the total and read in series. At the end of the loop, the accumulator will reference the total for us. So this example, we set accumulator to 0. Is there another number to read? Yes. Then we read the number. We add the number to the accumulator. Then we keep going adding. If there's a number to read, we keep adding until we finish. So the accumulator variable, for example, sum, if I'm doing addition, I will initialize it to 0. But let's say if I'm looking for a multiplication of a value from 1 to 50, 1 times 2 times 3 up to 50, you don't want to initialize the accumulator to 0 because we know 0 times any value is 0. But 1 times any value is 1. So if I'm doing a product or multiplication, I will initialize my accumulator, I will set it to 1. If I'm doing addition, then in this case, the sum addition, then I will make sure there's nothing inside. So I will initialize it or set it to 0. We also have the augmented assignment operators. Now, in many assignment statements, the variable on the left side of the assignment operator also appears on the right side of the assignment operator. So augmented assignment operator is a special set of operators designed for this type of job. Sometimes we use the term shorthand method. So for example, instead of saying x equal to s plus 5, I can say x plus equal 5. So this is the concept of, again, the accumulator variable. Now, instead of saying y equal to y minus 2, I can say y minus equal to 2. And z times equal 10 is saying z equal to z times 10. A divided equal b, saying that a equal to a divided by b. C modulus equal to 3, saying c equal to c modulus 3. Next, we talk about the Sentinel values. Now, a Sentinel is a special value that marks the end of a sequence of items. So for example, I can write a program, I'll say that while x not equal to 100, do something. Now, if y is 100, the loop will stop. So this means 100 is a Sentinel value. So a Sentinel value, again, here said that marks the end of the sequence of numbers. Or I may say y while I is equal to negative 99. So the Sentinel value can be any value. So here we say a program reaches a Sentinel, it knows that the end of the sequence of items will reach and the loop will terminate. Also, it must be distinctive enough so as not to make mistaken for regular value in the sequence. So for example, I won't use while I equal to 10 or not equal to 10. 10 is a very common value, so it can be mistake. Most of the time when we look at our Sentinel value, we may use negative 99999 or a number that is not common in our program. So example is when reading an input file, the empty line can be used as a Sentinel item. Now, how do we end a loop with a Sentinel value? Let's see example here. So here we have a program. We're going to use the concept of Sentinel value. So first we tell the user to enter an integer. The input exists if the input is 0. So first, when the user enter the integer, remember when you use an input function, the value is in string, so we change it to int. Now we want to keep reading data until the input is 0. We have our sum variable. This will be our accumulator variable. Now we say that why data not equal to 0. So this means 0 is our Sentinel value. If I enter any value, what I will do, I'm going to add that value to the sum variable. Sum equal to sum plus data, or we can say sum plus equal data. So let's say user enter 50. The previous value is 0. So the new sum will be 0 plus 50, which will be 50. Then we tell the user again, enter an integer, but enter input value. If the input is 0, we are going to exit. So we give the instruction to the user. The input exists, exit if the input value is 0. The same thing start. It's very important to give the instruction. So the input exists. With this tell us that if the user enters 0, then we are going to exit the loop, or in this case, the while loop. So we keep adding. So here we can add as many values as we want. The only way this program will stop and give us the sum, at the end, it will print the sum is whatever answer we have. It's when we enter 0, then it's going to print the total sum for us. So this is a very good example of, again, using a Sentinel value. So that will be the conclusion of these lectures. Again, these lectures will learn the basic concept of repetition structures, or called the loop in Python programming language. We focus on only 2 types of loops, the for loop and while loop. In our next lectures, we're going to talk about nested loops, how we can use a nested loop. Means we have a loop inside another loop, why we use it and how it works. So again, thank you very much and see you in the class.